Hello students, welcome to the course on Basic Electronics Engineering and the course code is EC101. This is the course for BTech first semester CSE, IT and FT students and second semester ECE students. Myself, Dr. Surojit Bosak, Assistant Professor of ECE Department, Guru Nanak Institute of Technology, Kolkata. And this is my official email address. Today, we are going to discuss about lecture number 3 from the module 5, that is feedback and operational amplifier. In the last lecture, we have discussed on positive and negative feedback. What are the different types of amplifiers? Feedback amplifiers are present based on their input output impedance, that is voltage amplifier, current amplifier, transconductance amplifier and transresistance amplifier. We have also derived open loop as well as closed loop feedback gain, input output characteristics of the amplifier, and we also a brief discussion was held for different types of connections, that is series connections and mixed shunt connections. So today we are going to discuss about feedback amplifier topologies, and the lesson objective of this topic is study the concept of both positive and negative feedback in electronic circuits. And the second lesson objective is study the different types of feedback amplifiers. And this topic is mapped with CO number 3. So let us start lecture number 3 from the module 5, that is feedback and operational amplifier, with the topic of feedback amplifier topologies. So before we going to the feedback amplifier topologies, different types of connections are required, essential for analysis of feedback topologies. First is the input connections. It may be in the input, it may be voltage or it may be current. If the input source is a voltage source, then the connection is obviously is a series connection. So this connection is called series mixing connection. Input with the feedback network. And if it is the current source, then the current source, that means parallel resistance should be placed in parallel, and the connections of input with feedback network is in shunt type. So it is called shunt mixture. And depending on the feedback or sampling, two types of also samplings are present. One is called voltage sampling, another is called current sampling. First one is the voltage sampling. That means if the output voltage is sampled by connecting the feedback network in shunt across the output, then voltage sampling occurs. And if the output voltage is sampled by connecting the feedback network in series with the output, then the current sampling takes place. Now, so this is all about input and output connections. Now we move for the topologies. What are the different, there are mainly 4 feedback topologies are present. See, the output signal in a feedback amplifier can be sampled by connecting the feedback network either in shunt with the output, that is voltage sampling, or in series with the output, that is called current sampling. In each type of sampling, the feedback signal can be returned to the input in series with the externally applied signal, which is called series mixing, or in shunt with the external signal, which is called shunt mixing. So based on the different combinations, there are 4 feedback topologies are present. First one is the voltage series feedback. That means basically voltage sampling and series mixing. Second is the voltage shunt feedback. That means actually voltage sampling and shunt mixing. Third one is the current series feedback. That means current sampling and series mixing. And fourth one is the current shunt feedback, or it is called current sampling shunt mixing. So let us discuss one by one. So first we start from voltage series feedback, or simply it is called series shunt feedback. So it is voltage series feedback. That means voltage sampling. That means output signal must be a voltage. So voltage sampling and series mixing. Series mixing that ensure that input source is a voltage source. See, so Vs input source and V0 is the output. So see, voltage sampling. First one is the from the output is sampled. Sampling connection first, then input connection. That is why voltage series, voltage sampling and series mixing. So in this type of feedback topology, a part of the output voltage V0 is sampled through the feedback network as connected to the input voltage Vs is in series. Therefore, the voltage gain of the basic amplifier in absence of feedback, that is say Vf equal to 0, is given by A equal to V0 by Vs. So in absence of feedback, that is Vf equal to 0, so Vs and Vi is same. So it can be written as A equal to V0 by Vi. Now, with the application of feedback, say feedback signal is Vf equal to beta into V0. Therefore, Vi, that is the input of the amplifier, is Vs. Vi is equal to basically Vs minus Vf for negative feedback, considering negative feedback. So Vs minus beta into V0. Now V0 is equal to basically A into Vi. So just put the value of Vi from here to here. So A Vs minus A beta V0. Now we know that the overall gain with feedback AF is obtained as, that is called closed loop gain. Is basically it is a ratio of V0 by Vs. So which is A by 1 plus A beta. Therefore, the voltage gain actually reduces by a factor of 1 plus A beta. Next, we have to calculate input impedance. Actually, for all these four topologies, first you have to determine the voltage gain, that is the closed loop voltage gain. Then you have to determine the input impedance and then output impedance. So this is the closed loop gain for voltage series feedback topologies. Now, what would be the input impedance? The input impedance of the amplifier without feedback, say Zi, which is Vi by Ii, and Vi is Vs minus Vf. Vf means, so Vf means beta into V0. Again, V0 is AVi. So it is Vs minus A beta Vi by Ii. Therefore, after simplification is Vs equal to Zii plus A beta Vi, or it is say Zii plus A beta Ii into Zi. Therefore, Vs equal to Zii into 1 plus A beta. Now, input impedance with feedback, say Zif, which is represented as Zif, which is Vs by Ii impedance. So, which is basically Zi from the earlier expression, Zi into 1 plus A beta. That means, thus the input impedance with series feedback is given by the value of input impedance without feedback multiplied by a factor 1 plus A beta. And this applies to both voltage series and current series feedback topology. Higher input impedance is obtained by series mixing of the feedback signal. So input impedance is basically with feedback is increased by a factor of 1 plus A beta. Next, move for the calculation of output impedance. How we can evaluate or how we can determine the output impedance? The output impedance can be obtained by applying a voltage source V at the output that will result in a current I with source signal shorted. That means Vs equal to 0. So output impedance, for the calculation of output impedance, you have to take that Vs equal to 0. So let Z0 be the output impedance of the amplifier in absence of feedback. Then voltage V equal to I into Z0 plus AVI. Now we have already given that Vs equal to 0. That means Vi equal to minus Vf. Therefore, V equal to IZ0 minus AVF. Therefore, IZ0 minus A beta into V. So just simplify V plus A beta V equal to IZ0. So in the presence of feedback, the output impedance, say, represented as ZOF, that is the output impedance with feedback, which is a ratio of V by I. So it is Z0 by 1 plus A beta. Thus the output impedance of the feedback amplifier with feedback is reduced by a factor of 1 plus A beta. Clear? So the output impedance is reduced by a factor of 1 plus A beta. The same behavior is observed for voltage shunt feedback amplifier. Hence, the low output impedance is observed for voltage sampling topology. A voltage amplifier should always have high input impedance and low output impedance. Next is the voltage shunt feedback. Voltage shunt means, so this is the circuit. Voltage shunt, that means voltage sampling, and current shunt, shunt mixing connection. That means if the shunt mixing connection at the input, that ensures that your input source must be a current source, and voltage sampling, that ensures that the output signal is a voltage. So a current source at the input and voltage source at the output. Okay. So therefore, sorry, here a part of the output voltage V0 is feedback in shunt with the input current signal Is. For this topology, the gain of the feedback amplifier has the dimension of basically impedance, because here input is a current source, output is a voltage, so voltage by current, so it is a impedance. And the feedback fraction has the dimension of admittance, that is current by voltage, as is clear from the equation of A and beta, which is given below. So the voltage sampling shunt mixing type of feedback topology has a current signal as input and a voltage signal as output. Okay. So the gain without feedback, A is V0 by II, and the feedback fraction beta is equal to IF by V0. So when feedback is applied, that is IS equal to II plus IF. So which is II plus beta into V0. Therefore, IS equal to II plus A beta into II, which is say II into 1 plus A beta. So from this expression, gain, voltage gain with feedback is given by AF equal to V0 by IS. So which is AI, A into II by II into 1 plus A beta. So which is basically A by 1 plus A beta. So voltage gain has a dimension of impedance, whereas closed loop gain, whereas open loop gain is also a dimension of impedance, but the feedback fraction is a dimension of admittance. That means the amplifier gain without feedback is reduced by a factor of 1 plus A beta after the application of feedback. So which is basically same as voltage series feedback. Okay. So in the next class, we discuss on input impedance and output impedance of voltage shunt feedback. So let us stop here. Thank you. Thank you so much.